My name is Dr. Gregory Kriehn, and I'm an associate professor within the Electrical and Computer Engineering Department in the Lyles College of Engineering at Fresno State. I am participating in the Summer 2013 Teaching Innovations Academy, and I'm redesigning our ECE 71 Engineering Computations course, which is a fundamental C programming course required for electrical and mechanical engineering students. The primary reason why I'm redesigning ECE 71 is that even though approximately 50% of the students receive an A or a B, between 30 to 40% of the students receive a D or an F, and students must receive a C or better in the class to continue within the engineering curriculum, since it serves as a prerequisite for other ECE classes. I believe the factors in the ECE 71 that contribute to a high D and failure rate are a lack of motivation among students, and because some of the course content is very complex. This is because ECE 71 is an out-of-major class for mechanical engineering students, and both mechanical and electrical engineering students typically dislike programming. Most students also have little to no programming experience, making some of the latter concepts, such as multidimensional arrays and pointers, difficult to understand for novice programmers. Students therefore struggle not only with syntax, but also more fundamentally with the algorithmic, logical, and sequential thinking needed to solve complex computational programming problems. The key elements in my course redesign center around using the supplemental model mentioned in the National Center for Academic Transformation by retaining the basic structure of the class while supplementing lectures with technology-based out-of-class activities, and by creating a more active learning environment within the classroom. Since C programming is highly technical, out-of-class activities such as online lectures, screencasting, and YouTube videos may help teach students fundamental programming concepts, such as data types, sequential and conditional statements, loops, arrays and pointers, structures, and file I/O. Activities in class can then be focused on programming examples with the students in the engineering computer labs. Significant time can then be dedicated toward addressing students' logical and syntactical errors, which will help them adapt more quickly to efficient programming techniques. When ECE 71 was last taught, the vast majority of the time in class was spent talking about lecture material and illustrating programming examples, with limited time available for the students to program. Furthermore, when I first arrived at Fresno State 10 years ago, the department taught ECE 71 as a pure lecture class within the traditional classroom environment. However, over the years, I've realized that the best way to teach students a new programming language is to use the same methodology used to teach a new spoken language: direct cultural and language immersion. This is the primary factor in motivation in moving ECE 71 toward a more active learning environment. By moving the class into the engineering computer labs, I have provided students with the opportunity to work more directly with the computational tools used to develop their source code and compile their programs. In addition, opposed to just using a basic text editor for coding, I have begun incorporating the use of an integrated development environment, or IDE. Both of these changes have helped immerse students into programming, but there is still only so much time that can be devoted to hands-on, in-class activities when most of the class period is devoted to lecture material. Developing online lectures and partially flipping the classroom should help students engage with programming more directly, and allow me time to focus more directly on solving their logical, algorithmic, and syntactical errors and misconceptions. ECE 71 has been strongly aligned with the student learning outcomes of the Departmental Student Outcome Assessment Plan, or SOAP, due to the nature of our engineering ABET accreditation requirements. As a department, we have formally identified which learning outcomes are relevant to each course within the curriculum, and which outcomes need to be assessed each semester. Therefore, ECE 71 does not require further alteration to align the course to the department's SOAP. Assessment activities simply need to occur throughout the semester. For ECE 71, the engineering outcomes to be assessed are 1. To have the ability to apply knowledge of engineering sciences and engineering design to solve engineering problems. 2. To have the ability to design a system or component or a process to a set of specifications. 3. To have the ability to understand technical instructions, interpret reports, and documents prepared by others. And 4. To have a broad education and knowledge of contemporary issues, necessary to understand the impact of the work of engineers in society. Using direct assessment methods, I plan to examine homework, projects, quizzes, and exams as they relate to solving engineering problems. following coding specifications and understanding technical instructions. Knowledge of contemporary issues will be addressed by coding a large project at the end of the semester that will require students to use current programming methodologies, and by the use of the NetBeans IDE, or Integrated Development Environment. The general timeline for a fall 2013 implementation of the course redesign is to create 6 to 7 online lectures and screencasts throughout the semester, which amounts to around 25% of the lecture material. The videos will be posted on Blackboard or via Fresno State's streaming server ahead of class time, and quizzes will be given to students to verify they have spent time out of class studying the online lecture material. In addition, I plan on integrating Blackboard more tightly with ECE 71 than in years past, primarily to give students real-time feedback about how they are doing and so that I can more quickly identify struggling students and optimize their potential for success. Because I have spent the past 30 years immersed in computing technology and software, I consider myself quite adept at interfacing and adapting quickly to new technology. But one of the most critical things I learned at the Teaching Academy is how to use Google Drive to create a real-time collaboration environment. Google Drive allows for third-party additions, and a company called Neutron Drive has created a coding development environment that allows for real-time collaboration, code revision control, color syntax highlighting, and auto-indentation within Google Drive's base platform. I'm particularly excited about an easy way to introduce code revision control to the students within this environment, since students often overwrite working programs with code that no longer works, and then they cannot figure out which changes broke their code. If students choose to use Neutron Drive, they will have a working history of all prior revisions of their code, which should help them considerably when debugging their programs. I have previously tried to introduce formal code revision control in the ECE 71 with programs such as Subversion and Git, but for students first learning how to program, it was very overwhelming. Because Neutron Drive uses Google Drive's collaborative real-time environment and adds a programming development environment with code revision control on top of its platform, this will provide a much simpler solution for students first learning how to program in ECE 71. The biggest concern that I have about my course redesign is the time required to develop video lectures. I have searched for existing online C programming lecture material, but most of it is written from a computer science perspective opposed to an electrical engineering computational perspective, meaning I will have to develop most, if not all, of the video lectures myself. I can use Linux tools such as FFmpeg to perform high-quality screencasting and with lecture slides, and use the NetBeans IDE to demonstrate coding examples for the videos, but I'm concerned about the amount of time it will take to edit the video content into something usable. Hopefully this process will not prove to be too overwhelming, and if successful, I plan on increasing the online content up to 45 to 50% of the lecture material during subsequent semesters. This concludes my plans for redesigning the Electrical and Computer Engineering's ECE 71 Engineering Computations course within Lyles College of Engineering at Fresno State. I have enjoyed participating in the 2013 Summer Teaching Innovations Academy, and I thank you for your time while listening to this video.